community tended to overly mystify this assumption, which was solid, which is ICS is different.
Welcome everyone to the Industrial Security Podcast. My name is Nate Nelson. I'm here as usual with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and guest of our show today. Andrew, how are you?
I'm very well, thank you, Nate. Our guest today is Ron Fabella. He is the Chief Technology Officer and co-founder at Synsaber. And, our topic is living at the edge, which, Ron is going to be talking about getting visibility into edge devices, looking at what's happening deep into our monitoring and control networks.
All right, then without further ado, here's you with Ron Fabella.
Hello, Ron, and thank you for joining us. Before we get started, can you tell us a bit about yourself and about the good work that you're doing at Synsaber?
Sure. So again, Ron Fabella, CTO and co-founder at Synsaber. My background, I started in the Air Force at seemingly decades, ancient times, but always in cybersecurity. Before it was called cybersecurity, it was called InfoSec. And after I got out of the Air Force, I went and became a defense contractor, doing everything from red teaming pen tests to high-level policy reviews and risk assessments. But that's where I got to fall in love with industrial control systems. This was around the time, early NERC, ARRA grants, kind of the things in the 2000s that built up a cyber practice in industrial. I got to go do and really fell in love. So I've been on site, oil and gas, electric utilities, manufacturing for most of my career as a consultant. And a lot of that time was from an attack perspective or a practical application of risk and attack. And now at Synsaber, I get to focus on defense, which is, for me, a much more fruitful conversation nowadays.
So, it's interesting that you have, a background in red teaming. Let me ask you, you're on the defensive side now. You have a background on sort of the white hat offensive side. I've concluded, I've maintained for some time that if a defender wants to design a strong defensive posture, they really need to understand how they're being attacked. Saying I have 73 defensive technologies out there, let's deploy one of each there, I'm done. In my experience, doesn't work. I mean, do you find that you're using your attack knowledge day by day to design defenses, to evaluate defenses? How relevant in your experience is attack knowledge to defenses?
I think there's two halves. One is at the strategic level, meaning knowing that there are practical applications of theoretical attacks. So we hear all the time in the news about, this substation or this refinery. It seems so far away, but the understanding of practical attack methods, and not only that, but more importantly, the potential impact if those attacks were successful, helps tremendously at a strategic level. It moves boards, CISOs, budget, and I think what we're seeing currently is it moves it as much as the specter of compliance or regulation. But from a tactical level, I do think understanding how an attacker may penetrate or disrupt your process does give that kind of theory crafting insight to how you should defend. Now, defenders have a unique position in that it's their home turf. They know exactly, the commonly asked, "What's a bad day at the plant?" They know that. They know what assets they have. They know what networks they have. They know typically if contractor access, et cetera. They know all these attack vectors. But what they may lack is kind of that observation bias of who and why and what would an attacker want to do if access was provided and if an opportunity were there. And it helps give that context as to how, not necessarily in just choosing the technologies that they need, but maybe prioritization, which ones to choose first, or maybe they should focus on processes and people as opposed to technology. So I think it informs them in a way that provides the other half of context when it comes to reducing overall risk and impact.
And our topic is, living at the edge. It's visibility into the edge of our industrial networks. Now, we've had a fair number of guests on the podcast in previous episodes talking about, looking at networks, looking at traffic, looking at what's happening. And the sense I get is that most of the time, with those guests, or just with the customers I'm interacting with at Waterfall, a lot of that monitoring tends to start at the highest levels of sort of the Purdue model, at where the systems are connected to the IT network, the sort of next layer down systems, the systems that in a sense use the same technology are the most like the IT network. You seem to be coming at this from the other direction. Can you talk about what you're doing and why you're doing that?
Absolutely. There's some interesting kind of corollaries to enterprise. Back in the Air Force, in enterprise and IT, there was that first focus on the perimeter, and I think for industrial control systems, especially when you put in monitoring or protections or firewalls, that's the natural first step. What we've seen in the last decade is that while that may be the natural first step from a either scalability or even just checking the box from a regulation stance, it didn't provide a whole lot of value from an operational stance. There's not a lot of industrial traffic that transverses all the way up to an industrial DMZ or through an industrial perimeter to the enterprise. Most of the operational happenings, the data happens in an east to west fashion. It happens along the process. And some of it does go up to an HMI or an OWS or an EWS or a historian, but not all the way up to that perimeter. So all of these things that we talk about, all these core tenets of OT monitoring, we talk about asset visibility or threat detection or baselining. It's not really the fault of current technology or predecessor technology that they're not providing a lot of values. They're not getting the data that's necessary to provide that valuable insight. So I think when we talk about edge visibility, and how our networks in industrial have modernized to create more networks down closer to the process, there's a wealth of data there that can be used both for security or efficiency or other insights that's just waiting to be used in a useful and scalable way.
Okay, so there's value at the edge, but in a sense we're getting ahead of ourselves. I'm using these terms: visibility, edge. Can you talk about the what first? What is visibility at the edge? What does that mean to you?
To me, it's, obviously this is all in a cybersecurity lens, but it's something that our operators have done for decades now. It's getting the telemetry, what's going on in the process from everywhere that the process has, and using that in a central location, either for control or status or things of that nature. We saw this same type of, kind of what question happen in enterprise with SIM, where it wasn't enough just to have perimeter defenses. You wanted to aggregate and collect data points from a variety of different sources, and then begin to ask questions of that data. What we're seeing in security and industrial is a similar focus, which is, what are the use cases? What are we trying to defend against? Is it the basic use case of we just need more awareness of what's going on in our network? That doesn't necessarily have a sexy security component to it, but it's the foundation of any program, whether it's security or operations. And what we're seeing in OT monitoring, especially at the edge, is that the type of data or the type of network traffic or the type of insights that can be gained just from going a few layers deeper from the data collection is exciting. And so what we're trying to do is open the apertures to try to shine a light on those dark areas where an owner operator or even a security operator says, well, that's industrial. It's kind of that dark place that we don't know about. That's what we're trying to reveal with more telemetry, more monitoring at the edge. We're too far along in kind of the security journey to still have well, I'm not sure type of response to whenever a ransomware attack happens or some incident occurs. And that's what edge visibility is really looking to solve.
Andrew, we've also used this term edge on plenty of podcasts before, but we've never really got into it. So could you tell me what constitutes the edge at an industrial site?
Yeah, so edge is a term that came out of the industrial internet. In the industrial internet, there's the cloud, and then there's the sort of the stuff closer to the physical process, the stuff wired into the physical process. There was only edge and cloud. There was, in a sense, nothing in between. I think Ron is using the term a little bit more generally. I think, if you look at a sort of a classic Purdue model, I don't know, power plant where you have the business network, and then you have a DMZ, and then you have the plant-wide systems that all the generating units share, and then you have the DCS, the control system for each generating unit, and then you've got safety systems, connected to the control system. You've got PLC networks, that layer upon layer upon layer of defenses, classic Purdue model, defense in depth. The very bottom layer, the computers that are connected directly to the physical process, I think is what he's referring to as the edge. These are programmable logic controllers. In transmission grids, these are the devices in substations of 1,000 kilometers away, remote terminal units and protective relays. This is the equipment in compressor stations all the way down natural gas pipelines and so on. This is the lowest level. And, I'll repeat what I said a moment ago. In my experience, people tend to start their visibility deployments, their intrusion detection systems, their monitoring systems. They tend to start those systems at the higher levels of the Purdue model, in the networks, let's say the plant-wide network and the DMZ, that are most closely connected to the business network. And the business network is, of course, connected to the internet, which is, in a sense, the source of all evil. And so you tend to start monitoring the networks that are sort of closest to your threat, which is the internet coming in through the IT network. And Ron is taking the opposite approach. He's saying, no, there's enormous value in monitoring your bottom layer networks. And, there are challenges there. We're going to talk about these in a moment, but things like the protocols in the bottom layer are the ones that look the least like the protocols we're familiar with on business networks. And so interpreting that data becomes a problem too. So that's sort of some concrete examples of what we're talking about here. Okay, so we're looking at the traffic. We're getting insights. I'm curious, who in your experience tends to be driving this? Do the engineers already kind of know what's happening deep into their networks, and they're less interested, and the IT people are sort of completely new to the space and they desperately want to understand what's happening? Or is it the other way around?
I think the most common use case you see is the security team on the enterprise side, or the CISO, that has now been given the task of being responsible for managing risk within an industrial environment. And so they take inventory and they just say, well, we just don't have logs or network traffic or the things that they're used to in order to make those determinations. So I think it's still very lopsided from the IT side. What we're finding, though, is the kind of political capital spent in order to affect security change in enterprise or in industrial security isn't new. We hear all these stories about IT/OT divides and bring donuts to your operators. It's kind of played out now. It really is about, from the operations side, what value are you going to bring? So you're going to bring in some monitoring solution or some new perimeter defense or new requirements, but what is the operations side actually getting out of it? So the who hasn't necessarily changed. I think it is CISOs or the enterprise security side of the house driving the budget and the need. But really what we're seeing is that the operations side, rightfully so, has a seat at the table. And now they're starting to ask very informed questions like, well, what is it that you're looking for? What are the use cases? What value is this bringing to me to reduce downtime or to increase safety or reliability? And I think what we're seeing is a more informed operational community when it comes to cybersecurity.
You may not know me. I'm a techie. I always want to know how this works. How are you gathering this data at the edge? What are you looking at?
So I think for a lot of OT monitoring, it starts with the network traffic itself. And there's a number of ways of getting that. The 80% solution is there some sort of span or mirror port on a network switch that you could passively collect that data. Passive versus active is a huge discussion in our industry, as you know. And but that's usually the beginning, is taking network packets, traffic off of the wire, either through a span or tap, and doing some processing and analysis of that traffic. That could be everything from high level NetFlow like this device with IP and MAC talk to this other device with IP and MAC over a certain port. And that gives you kind of the basic visibility of just conversations between assets and devices, all the way down to the dissection of the protocols. And again, dissection or deep packet inspection they're not new terms, not even new for industrial. But when you look at the dissection of protocols, that's really where operations is occurring, not just that there's port 20,000 and DMP3s going back and forth, but what are the requests and responses? What are the function codes? Doing some statistical analysis or even some rule set analysis on the dissection of protocol traffic is really where the insights and the valuable can be gained. So network traffic is absolutely one way. Another way that we're specifically addressing that is really looking at it from a behavior stance, not from the threat intel side, like, oh, there's evil Russian hackers and here's how they behave in Ukrainian substations, but more of presenting that behavior to an operator, whether they're a security or industrial operator, and saying this is how your network is behaving on top of your process. It provides a huge amount of insight in areas that are not very exciting for us cybersecurity people. One example was operator or operator support having to go out to multiple sites and fix NTP or time shifting. Showing that behavior on top of the process just provides so much value to the protection of the system. And so that's one way. Another way is, again, doing the collection of that into a central location and providing contextual data around it. What I often see is that the IT side of the house sees a lot of network-based information, but they don't know if there's a process disruption. And on the operations side, they see if there's a process disruption. They're very break fix and they have all that telemetry. They have no context as to whether a network event or the cyber affected that particular disruption. So they're both missing one half of the same context and story. So as much as we can bring those two halves together, just think of the possibilities. Now we're able to respond to events, whether they're malicious cyber attacks or non-malicious contractor making a change on a PLC. Each side of the house and together they can respond to those events in a way that is safe, it's scalable, and it's not wasting anyone's time. So you hear a lot of terms, like I said, dissection, network traffic analysis. These are all tried and true things, but the crux of it is getting that information where the process occurs as opposed to the perimeter or the choke point. I think that's the missing piece in industrial security. And I say that with confidence because we've seen on the enterprise side this evolution where we started with perimeter defenses, then we put in firewalls, then we put in IDSs, and everything started at the perimeter. And then the realization of, oh, wait, we're going to allow all that traffic through. What about the edge, or what enterprise calls the endpoint? What do we do to protect that? And that evolved from antivirus to EDR, and now whatever XDR is nowadays. But it was this idea that you needed both halves of the data story in order to properly secure, and there wasn't a silver bullet that would meet all. And what I want for industrial cyber is to jump kind of, let's learn from that. Let's not spend another decade going from perimeter defenses to this, to that, the other. These are lessons learned that we can apply now to industrial and kind of leapfrog ahead and get both of our industrial and our security operators the data they need.
That makes sense, that if you've got sort of information about the physical state of the process, that's going to be very valuable to correlate with what's going on network wise. How do you get that though? I mean, you're monitoring a refinery. How do you know if gasoline's coming out the end of the refining process or not? And how do you know that so you can correlate it?
I think at a high level, so much of our process is modernized, and network traffic can be seen and analyzed to determine the health of the overall communication network. So if you're seeing more requests, more activity, or even an uptick in something as simplistic as error codes or exception codes within certain protocols, that could be a leading indicator that something on the process is unhealthy. I think, and this is more of a philosophical answer than anything, the operations side and the input from operators on what a process disruption is, or how they respond, or how they just interact with their control system as a whole, has been lacking from the security context. Security tends to come in and say, well, we know better. Here's all the things you're doing wrong. You're using insecure protocols. Nothing's patched, yada, yada, so on and so forth. But the security, the operations side has so much to provide in context data for security, like process disruptions, or this is what it looks like when we're getting ready to turn the plant from a maintenance side. These are things that they can put into the telemetry or the security of the collection of the system in a way that just bubbles that context up. So that's kind of a more philosophical answer to the question of, which half of the story do each of these players have? I think process disruption and network traffic analysis can go hand in hand, especially for the root cause analysis or the RCA portion where there is a disruption or there is an event. And what I think I'm hearing operators say more and more is we hear all these things about cyber. In fact, enterprises breathing down our neck with all these things. We want to be able to tell them, no, it wasn't cyber. This valve just broke. And it's such a simple question, right? Or such a simple ask. And being able to automatically collect that on scale, think of what a historian does for the process. Really, security and a SIM should be doing that for the security side of the process.
Admittedly, even after Ron's answer there, I'm still not totally clear on what all of this looks like.
Well, his answer was a little bit abstract. I think part of his answer is if you're parsing the industrial protocols, you can see values coming by that say, this is an out of bounds condition. Maybe another possibility. Ron's talking about sort of the value in having insight into what's happening in your process. So, to me, what makes sense, in addition to, parsing the protocols, is most of these HMIs have an alarm server, an alarm display. The alarm display puts up, text, flashing red, flashing yellow, when there's out of bounds conditions, when, a value leaves the known good state. And these might be because of, broken valves was Ron's example. But if these alarms went into the SIM would be aware of process upsets as well as, weirdness on the network or weirdness in the host within the antivirus system. If when the operator resolves an alarm and says, oh, I've dispatched a crew, they're going to replace that valve, and puts an annotation on the alarm, send the annotation into the security center so they have that information as well. Or, the operator has a process, some kind of process, I'm weak on the details, for knowing what change requests are authorized in the network on their shift. If that information is also sent not just to the operator, but to the SEM or to the SOC, the Security Operations Center, and they see weirdness halfway through the shift, they can look and say, oh, there is a change order. There's 8 people, dismantling the network. Okay, that's why these communications are failing. So, context like that, I agree, is very valuable. And you can get it by sort of looking deep into the protocols and figuring out for yourself. You can get it because the higher level systems are pushing it to you. You can get it a couple of different ways.
Cyber attacks with physical consequences more than doubled in 2021. For industrial victims, the most common consequences were production outages at multiple sites. Most of the attacks were ransomware. And 2021 saw the first cloud-based ransomware attack. That attack compromised 1,500 businesses in the space of 45 minutes. These and other insights are included in a new threat report, co-authored by Waterfall Security Solutions and the new ICS Strive Industrial Incident Repository. For your copy of the report, please visit icsstrive.com. That's ICSSTRIVE.com.
Okay, so you've talked about sort of analyzing the data in the SIM a few times here. I remember this was over 10 years ago when I was at Industrial Defender. We produced the world's first industrial SIM. To my knowledge, Industrial Defender no longer sells this. In part, it was because back in the day, we kind of learned in the late noughts, we're talking 08, 09, what people seem to be looking for is not an industrial sim. They kind of wanted industrial data in their enterprise sim. Now, I know today people are out there selling what amount to industrial sims. What's your take on this? I mean, where does your data go, and what do people do with it when it gets there?
You couldn't have said it better than myself. I think specifically for Synsaber and just what I've seen in the few decades that I've been working in this space is that really nobody wants a separate OT sim. Now, I think Industrial Defender was probably a decade ahead of their time because, to your point, now all of a sudden it seems like everyone's buying industrial sims specifically. So, what's the mismatch? I think early on, we were constantly trying to convince folks that they needed visibility or monitoring or whatever the term of the day was in OT. And there just wasn't enough oomph there. There wasn't enough compliance regulation. So Enterprise happily had their SIM, they had their Splunk, they had their QRadar, Logarithm, whatever the case may be. And no one wanted to really pull the trigger on a whole other duplicated SIM. There's a lot of cost that comes with that. But then there was this push, huge messaging, both from government vendors, folks like us, who said, no, this is an important thing. The threats are real. You really need to do this. And so the market kind of swung at the other end of the pendulum and said, okay, fine. Give us the walled garden, all-in-one blinky box with the maps and the dashboards and the pew-pew stuff because we want our industrial to be secure. And that happened, especially with a lot of the current focus in industrial security. OT monitoring has to be at the top. What we've seen now is those solutions have been put in, and kind of mentioned before, it was a Band-Aid. Give me the blinky box. We need to do something, and so they put it in, and now they're going, well, wait, what value are we getting out of this? Like, what are we actually looking to solve in the industrial space from a security stance? And this is primarily enterprise or CISO based organizations doing this. And what they're looking at is they're saying, well, wait, we already pay too much for Splunk, or we already have all this infrastructure and training and process around events, collection, correlation, response. And now we have to go into this whole other single pane of glass just to get industrial related context. And so I think the veil's been lifted. We talk about, industrial being so different. Well, to a security person, it's network protocols going between devices. At least that's their first thought. And so some of the basic questions of, can we just get that network-based traffic, that even the raw data, forget analyzed data, can we just get that into our Elastic instance and then we can continue about our day? The big focus with that is the market had really oversold this idea that you needed a whole nother solution because industrial was so different. What the operator really is saying is, we need that same data. We need context and understanding of that data because industrial is indeed different, but we need that in our existing tools and technologies. We don't need a 10th or an 11th single pane of glass just for industrial or just for the power plant or just for this line of business. I mean, imagine that, Andrew, if you had an enterprise organization and for every line of business, they bought a different SIM because they were sold some idea that this SIM was better for the finance side of the house versus the operations side of the house. That's how we're treating industrial, but organizations don't really treat industrial that way. So when we talk about OT monitoring, Synsaber's focus really is on not being yet another SIM. I think that idea and that hypothesis maybe worked great 10 years ago. Security operators, industrial operators, they don't want another single pane of glass. They just want that data in existing. So what we're doing from an analytics and collection side is we're vendor agnostic in two ways. One is we don't care where you send the analyzed and curated data. It could be to multiple SIMs, it could be to the cloud, MSSP, wherever you need that data, it's your data. You should control where it goes. The second, though, which is important, is the context around that data. So again, we're doing, and a lot of predecessor companies do this as well. You're doing the the data analysis, the protocol dissection, all the things you need. But a lot of the raw materials are going up to their own SIM, and then they're doing magic. And we're turning that upside down. We're saying the analytics can be done at the edge. They can be done on scale to where you get near 100% visibility. And not only that, you can send the context up as well. This isn't just raw data, raw packets. This is really, hey, we've seen this baseline change, or we've seen an uptick in exception codes in this protocol. We're answering the questions that allow for intelligent discussion on the SIM side, not in our SIM, not the way Synsaber views it, but the way that the organization views it, because they know their systems. Industrial security operators, doesn't matter. They know their systems better than anyone else, security vendors included. And what they really need, though, is the automated collection, the data dissection, the data reduction. So in that way, they can go about their security program and their business in a way that's effective and scalable.
In a sense, another sort of lesson from the past, when I was at Industrial Defender, I remember a customer or a prospective customer, I think at a trade show or something, coming up and saying to me, you need to know a lot to be able to use this tool that you've created. And I recall being insulted because, we were really good at producing sort of sweet user interfaces. We'd had our fingers burned a few times in the past trying to push something into the industrial market that wasn't, dead easy to use. And so we produced a really nice interface to the SIM. And I was insulted. What do you mean you have to know a lot to use this? And he said, no, it's not which button to press. That's obvious. You did a good job there. You've got an alarm here that says, I don't know, a message just came through that, hasn't come through very often before. It's probably important. And you look at it and go, what the heck is that message? What does that message mean? You need to know a lot about the system in order to interpret these alerts. Is that still true? I mean, has that hurdle been crossed here?
The short answer is yes. I think now extracting that data or even enriching that data, what is read coil, mean, and putting that into something human translatable is something that is still target rich. It's something that we can still provide, but that's been the problem of security since the dawn of time, right? Which is, this IOC, it flagged and snort, but what does it actually mean, right? In the context of my system. I think for much of early industrial, even going back to Industrial Defender days and my early days, the community tended to overly mystify this assumption, which was solid, which is ICS is different. You even hear folks say, even in the early days, where it's like, you can't just take IT tools and put them in OT. It's completely different. Or Ron, how would you understand this protocol? It's so different. Well, the funny thing is, most of these protocols are they're standards. You can go investigate them. You can go read about them. They're well documented. Nothing's encrypted, so you can actually gather and extract this data. I gave a talk at S4 about this, where I think just early industrial security, we wanted to be this unique unicorn that only we understood and nobody else could possibly understand unless they come to us for help. And maybe we overplayed our hand. I think with knowledge, with understanding, the gap between understanding industrial process and being able to secure it has closed. And I think that's exciting. I think for us as security-minded folks, that means we're spending less time educating and convincing folks of security implications or impact in the industrial environment. We're spending less time convincing industrial operators that bad things could happen because of, the basics, open ports in a firewall or unpatched systems. Everyone understands now. And now the pivot is, well, how do we execute? How do we execute on scale? How do we get this data analyzed and sent to the systems we need? How do we respond? And those are the more important questions, not, does your dissector work better than the competitors? No. It's leveling the playing field and saying, no. Are we providing the right analyzed data to the right places so that way these more important questions can be answered?
let's leave the SEM. Let's go back to the edge. The edge is our topic. Um, you know, can you talk about what it means to be monitoring the edge? I mean, in a refinery, I was at a small refinery. I think they had hundreds of PLCs. A large one has got way more than that. Sometimes the edge is very far away. In a pipeline, the edge is, in the pumping stations, in the compressor stations, 1,000 kilometers away. Um, you know, what are the challenges out there? How do you deal with those challenges?
It comes down to some basic physics, right? It's geographic uh, separation. It's the ideas of scale, of communication. It's problems that can be solved. And so when you think of a substation, my local EPB, they probably have 70 to 100 substations in my area. They're all geographically and separate facilities, each with their own small mini networks with a handful of devices running to distribute power. When we talk about the edge, that's both logical and physical. When you go into a refinery, there's multiple lines and cells and processes that may or may not be network segmented, but it's a big facility, so you don't necessarily think of it as geographically dispersed. But the edge is really down to that lowest part of the Purdue model, not talking about level 0 monitoring, but as close to the devices as possible. Because again, the idea that the process lives in this east to west traffic or in this one layer up type of network topology, that you can't gather the insights or the data you need from very high in that architecture. And what I found, both as an attacker and a defender, and just using the substation example, because I think substations, everyone understands, oh yeah, I have one of those in my neighborhood, and kind of get an idea for what it does. Attacking power or attacking substations, it's much easier for me to go down to my rural substation, pop the lock, plug my laptop into a network port on a switch, and now I have access to hopefully just that substation's network. What I found in my experience is that as networks modernized, not only did I have access to that substation network, I had access to all the substations on the ring. And I think we've seen that a lot, whether it's a manufacturing floor or a refinery. As networks modernized, the amount of east to west communication increased, even if the process didn't need it. And that, to me, more so than Shodan or the enterprise to ICS connection, that provided the most increase in risk from a network perspective than anything else. Because it was this idea, again, of a crunchy outer shell and a gooey soft center. As soon as I breach that network, I have access to all other production lines, all other processes from that one point when I probably shouldn't. And so when we talk about the edge, both logical and physical, that's really what we're talking about, is that monitoring of that bottom-up approach to not only give security insight. Evil Ron with a laptop went into a substation, ran Nmap, and started doing crazy things. But think about it. That's where all of our attack vectors are. It's the contractor coming in, making a change. It's a network going down. It's time shifting. It's also how you answer some of those so what questions, like, oh, well, we need asset inventory. Well, how do we gather that? What do we do with the data? It's just the foundation of so much insecurity, and it's surprising to me that it's been overlooked for this long.
So Nate, let me give you sort of a couple of concrete examples. Ron used the substation example. Let's look, 20, 30 years ago. Substations were connected to the SCADA systems, the central monitoring systems, over leased serial connections, modems. And some of even in refineries, the DCS might be connected to a bunch of PLCs through multi-drop serial. So a single serial line might serve a half dozen PLCs. If you take over one of those PLCs, you can send serial messages to other PLCs. You can send messages to the SCADA system. You really couldn't get to other parts of the plant. Serial just didn't lend itself to that. If you were in one substation, you could send messages to the SCADA system. You couldn't send messages to other substations. Your cable, your wire, didn't run that way. Nowadays, everything has an IP address. And to Ron's point, if you are on one of those networks, either because you've taken over a PLC or because you just have a laptop there, or, you have one of, from, 20 episodes ago, Mark Fabro's, he called it a leave behind attack. You break into the substation and you leave something behind there, and then you interact with, the laptop you left behind wirelessly from outside the fence. If you get any kind of access to one of those networks deep into the Purdue model, right out, at the connection to the physical process, he says, nowadays, you can talk from those networks to other device networks. You can talk to other devices. You can tell those devices to do bad things over the unencrypted protocols they're using. This is wide open, and increasingly, what we're seeing, the trend in the automation industry is to push, where practical, in many but not all circumstances, to push intelligence into the devices that are closest to the physical process. And so now these devices are not just talking to the SCADA system, they're talking to each other, they're coordinating local processes. So this is what he's referring to as east-west traffic between devices, traffic between device networks. This is all possible nowadays. And if you have an intrusion detection system or a network monitoring system higher in the Purdue model, you're monitoring the control center, you're monitoring the computers that animate the human machine interface. You don't see any of that traffic out in these other networks. Yet the possibility has arisen in the last 30 years for an adversary in those networks to manipulate those networks badly in ways that are never visible to the central system. And I think this is the point of his edge monitoring. We've been talking sort of about the problem technology wise in some depth here, but Synsaber provides edge monitoring technology and other stuff. You've sort of mentioned in passing what Synsaber does, but can you go on the record? What does Synsaber do? What do you provide? What's your focus?
Sure. And this is why I'm so passionate on this subject. Synsaber is an OT monitoring visibility solution. But again, we're not looking to be another SIM. We're doing all of the collection, analysis, all of that at the edge on the smallest devices possible. And we're not talking, if you're familiar with IDS or even other OT SIMs, we're not talking 1-2 U servers and kind of this bulk of processing that's needed. We're doing this on 1 core, 2 cores, 2 gigs of RAM, and on hardware devices that are small enough to fit in the substation and cost effective enough to deploy thousands, not just one at a choke point. And so that's really our focus, is that the edge data is so valuable. How can we solve from a technology stance in a way that we can collect that on scale, be cost effective, and really put the power into the operator's hands? The other thing we see in a lot of predecessor companies, and I understand it's almost like the Apple iPhone model of, well, if you control the hardware, it's very appliance oriented, then you control the whole experience. And what we're saying is, no. This is a software package. This is monitoring that you should be able to put on any device that you have, or a virtual machine, or anything else, especially with current supply chain challenges that we're facing. To lock folks into an appliance or a SIM or a device, it's just, it goes counter to what our mission is, which is to empower the operator, whether that's security or industrial, with the security data they need, and doing that in a scalable way. So that's really what our focus is. Yes, it's OT monitoring. It's the same, asset inventory, threat detection, baselining, et cetera. But we're doing it in a way that you're not just getting a 2% look at your environment. Deploy this to every substation, to every network segment along the pipeline, because that's where operations happen. And that's where you're going to find the security disruptions, or you're going to find these things that occur. We're very, very focused on the operations side, where I would say previous thinking has been focused on the threat intelligence side. And to be honest, it's important, but if you don't have that operational data, the threat intel is just, it's history. It's you're doing an autopsy on the body. So it informs what we do and how we do it. But getting that edge data, getting it to the technologies and the tool sets that are already used in the organization, that's really our mission.
Okay, and you've been, deploying these products for some time. Can you talk about your experience when you put this stuff in? What do you see? What do your customers see? What's sort of noteworthy to them now that they've got that visibility?
I think the first thing we've seen is kind of the opening of the aperture of how much data is out there, or how many networks, how many devices, that basic awareness of, oh, I didn't know this network segment had these 20 devices speaking Modbus, et cetera, et cetera. So just the reveal of their own network in a way that's real time and automated, they're not doing lockdowns and seeing the PLCs. That has been eye opening, literally, for a lot of the implementations we've been doing. Because again, the focus may have been on a choke point, and they maybe had a false sense of security or a false sense of, oh, we understand our network. When you put in something this efficient or this specific, and they go and they monitor a remote facility or a remote substation, and they see all of the communications, the devices, it's literally eye opening. And the fact that it can be delivered to a centralized location or multiple, not our centralized location, but to whatever SIM or whatever data lake they have, it becomes so frictionless that we've seen our customers become creative. They go, oh, well, you're telling me this is, sending so many requests and responses, and it's using this protocol, and there's these exception and error codes, and you're giving me all this detail. But Ron, have you thought about X, or have you thought about this use case? We've had customers say, have you thought about wireless? We go, absolutely. Like, if you're at a substation and you want to see if Ron's iPhone has walked into the area, that's valuable, right? So what we've seen is, as we revealed all of the bits and pieces of their network environment and how they're interacting, they've seen the possibility of applying this to other use cases, both security and non-security. And that, to me, is the most exciting. So as an example, if you look at different plant architectures where there are remote connections coming in, the operator understands this, or the asset owner understands this. They have a network architecture diagram that shows this connection coming in. They know the network architecture of where that connection is going down, maybe to the unit level, all the way down in the plant. But what they lack is the understanding of what's going on with that within that communication, which is why I take some exception when folks say, oh, people don't even know that contractors know. No. Everyone knows this. It has to be approved. And in fact, vendors that build these plants, this is part of their warranty or their services offering. So the network comms are known and the external connections are authorized. But what is lacking is just that level of detail of, this is what they're using that communication for, or these are the exact parts of the unit or the network segment that they're interacting with. Here are the protocols that they're interacting with. And one of the biggest questions that we've asked in this scenario answered in this scenario for our customers is, the vendor said that they were just collecting status data, or it was, collecting logs. But what we really want to know is, are they sending any control commands, or are they making any changes to the configuration of the PLCs or the unit or anything else? That's what they're, I don't want to say worried about, but that's their biggest point of concern, is this idea of trust but verify. We've allowed them to come in. We've allowed them to have this network connection. They're telling us they're only doing this, but we want to inspect everything, see it all the way down at the unit level, and ensure that that's all they're doing. And so there's this, I don't want to say paranoia, but it's this healthy concern of allowing this third party or this external communication in and understanding how big of an attack vector that could be. And we're providing that level of visibility that they're not getting if they were just to monitor the connection at the highest level. Again, the goal is, and the mindset is, that these operators know their environments better than I do. So to give them a tool set that allows them to be creative and to do that is amazing. And that's what we've seen time and time again, even with, and especially with, customers that already have maybe an entrenched idea of what OT SIM or what OT monitoring should be. They're actually the most receptive to, oh, like, wait, we can do this at the edge? I was told that we couldn't. I was told that it was too expensive. I was told this, and that. And that has been the most encouraging for us going into the field, is seeing that veil be lifted and the possibilities that come with it.
Well, Ron, this has been great. Thank you for joining us. Before we let you go, can you sum up for our listeners, what should we take away from this?
I think there's a few main points. The biggest one is that the process lives at the edge. And so if we ever hope to monitor, secure it, make it more efficient and safe, we have to start focusing on where the process lives. And so that's why, we as a monitoring company have focused so much on monitoring at the edge. There's a wealth of data that occurs there. And to have that data just be kind of locked away and not being utilized is just a tragedy at this point. Some other things, not everything needs to be this overly complicated or these very mystical ideas around security. As much as we can demystify and unlock that data at the edge and get it to where the operators, both industrial and security operators, need it, the more opportunity we're going to have to empower those operators to secure their own systems. I think the other big takeaway, both from a messaging and just being in the industry so long, is that there was this emphasis on security or the government being the hero in the story. And I think really operators know their systems better than anyone else in the world. What they need is tools and technologies to help automate or to help make more efficient their job now that security is at the forefront. And that's really where the industry needs to move to, is how can we empower them with tools, technologies, new ideas, so that way they can go and defend their networks the way they know best. For us at Synsaber, that's our focus. I mean, you can find out more information at synsaber.com. We're on all the social medias. It's really about just having a conversation on what can technology do for our operator community in a security focused way. And thanks for having me on the podcast. It was really, really enjoyed discussing with you this passionate topic of mine on edge visibility.
Andrew, that was your interview with Ron Fabella. Do you have something to take us out with?
Yeah, I mean, my understanding, my takeaway here is that for a decade, the trend in security monitoring for industrial operations has been to work sort of steadily deeper into the process. And what Ron is saying is that it's possible nowadays to monitor the entire network, to go as deep as you want into those networks. It's possible. It's practical. It's not even that expensive. So, sort of another takeaway from this episode is sort of Ron's insight that, look, understanding what's happening deep into the network between the PLCs, between the RTUs, understanding this stuff is not as hard as it's made out to be. It's protocols, it's messages, it's computers. I mean, they may not be Windows computers, but they're computers. And, what I hear him saying is that the time has come to see the whole picture and, to make sense of it. And, he says it's possible, it's practical to see everything and make sense of everything in our central security monitoring operation. So, this is good news. I wish him the best.
Okay. Well, then, thanks to Ron Fabella for sharing all that with you, Andrew. And as always, Andrew, thank you for speaking with me.
It's always a pleasure, Nate. Thank you.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.